Assalamualaikum warahmatullahi wabarakatuh. And a good day everybody. Now we are continuing our chapter in moment and also couple. So we have done the introduction to the moment. What is a moment? Was actually the concept in moment of forces. We have the force and also the distance, which is the must be perpendicular to each other, and also the couple. So the couple meaning that they have two forces, different direction but the same magnitude, separated by a perpendicular distance from these two forces. These are parallel forces. Okay, so we have an example of moment of couple here. For example, we have steering here during a steady right turn. So now the person exert the forces shown on the steering. So because we want to a right turn, turning to the right, know that each forces consists of a tangential component. The tangent to the point E, there is a tangent to the tangent at this point E and also the point B, and a radial inward component determine the moment exerted about the steering column at O. So we have the magnitude of the forces at Newton. We have the magnitude of force at Newton because of the couple, because this one give us same forces but the different direction. Okay, so we can see this calculation. So the moment is equal to force multiplied by a distance. So the force is actually 8 Newton. So we need to find the perpendicular distance to this from here to here is actually is from here to here is the diameter is a 375, but we need to find is actually a distance between these two forces. We can, although it's 8 Newton, if the 8 Newton is just multiply just at this forces, but this one is radially inward. So we need to turn this steering. So we need to find this D, so not this diameter. So how we want to find this diameter D, the distance from the two separated forces. So we have the 0.375 centimeter. So we have the angle. So the angle theta here. So the angle theta is equal to angle theta here. So we can find this D by using the 0.375 multiplied by cos 30. So we will get the D. So we have the 8 Newton multiplied by this D. So which is 8 multiplied by 0.375 multiplied by cos 30. So equal to 2.60 Newton dot meter clockwise. Okay. So now we have another example. So a 500 Newton vertical force is applied to at the end of a lever which attached to a shaft at O here. So determine a moment about O. So horizontal force at A, which create the same moment. Smallest force at E, which produce the same moment. Location for 1200 Newton vertical force for the same moment, and whether any force from B, C, D is equivalent to original force. Okay, so how you want to find the moment about O? But we have this distance 600 mm, but the force 500 Newton is not perpendicular to this to 600 Newton. So we must either find the force with the perpendicular distance, perpendicular with the 600 mm. So we have the force 500 Newton here. So perpendicular to this point O is actually this D, not 600 mm. So we need to find this magnitude of the length of this D in order when to get the moment. So moment is 500 Newton multiplied by the D. So because the moment about O is equal to product of the force and perpendicular distance between the line of action, this is the line of action and also the O. So this D is perpendicular with this 500 Newton. So since the force tends to rotate the lever clockwise, this is clockwise, the moment vector is into the plane of the paper. Okay, this is direction to the paper. Okay, so F. So we need to find this D first. So 600 mm, which then change to the meter. Then we have this one, the cos 60. So we get a 0.3 meter. So finally 500 multiplied by 0.3. So the moment about O is 150 Newton dot meter. Okay, second question. Horizontal force means this vertical, this one horizontal, in x direction, which create the same moment about which create the same moment when we have produced in A. So we have 150 Newton. So this force is a horizontal force. We have already 150 Newton, the same moment as the produced in the part A just now. So F multiplied by a D. So this F must multiply by a perpendicular distance to the point O. So this one the line of forces, this one line of forces, but we have the line of the axis. So from here to here must be perpendicular to the line of action. So this one is a D is perpendicular. We need to find this D. So we have the 600 the hypotenuse by cos we have all the angle 60. So we have the sine 60 multiplied by 600 mm. So we get the D. So moment is equal to F multiplied by D. So moment is 150 Newton dot meter equivalent F multiplied by 0.5196. So finally we have the F. So F is a 288.68 Newton. Okay. Question part C. Part C, smallest force at A which produce the same moment. So how you want to find the smallest force? You must remember, so in the smallest force at A for the same moment is occur when the perpendicular distance to is a maximum to the forces when F is perpendicular distance to the O. So we have 600 instead of vertically just now. So we need to find the perpendicular. The force must be perpendicular to a distance O. So we have all the OA here. OA here, so we just find the magnitude of the force but the perpendicular to this OA. So MO, moment about O, equal to FD, moment about O is 150 Newton, equal to F multiplied 0.6. So we have the F 250 Newton. So when you can see here, at the part A, although the moment is 150 but the force is 500. Part B, or the moment is equal 150 but the force is 288.68. But here the moment is equal 150 but the force is 250. So it's the maximum force. So if you want to find the maximum force, the force must be perpendicular to the point that you want to rotate about it. So for O, so OA is a perpendicular. The force must be perpendicular to the level of OA here. Okay, so the part D. So part D is a location of 1,200 Newton particular force to produce the moment. So 1,200 Newton is somewhere from O to A here. So we want to find the location. So for example, we're not sure, we put the point B here. So this one is a vertical. We just multiply by a perpendicular distance to this line of action with the O. So we need to find this D. So 150 multiplied by 1,200 multiplied by D is D. So D 125 mm. But we want to find the location on arm OA. So we have this one. We have this D. We have this angle. We need to find this hypotenuse. So using the cos 60. So OB multiplied by cos 60 is equal to 125. The final O to B is 250 mm. Okay, the last part, whether any other forces from BCD is equivalent to original force, should be, I think we have already the answer, because all the forces are not the same value. So although each of the force in part B, B, C, D and E produce the same moment as the 500 Newton in part A, but none are, or it is not the same in the same direction or on the same line of action. None of the forces is equivalent to the 500 Newton forces, because this one is a 500, this one is another one, this one another one, this one also another one. But all this one is same moment, but the different forces, different sense, different direction. Okay, I think that's all in this chapter, moment and couples. But here we have finished the chapter number I think was the chapter number 4 here. So you must understand the concept, the definition of moment of forces. The force, the line of forces and line of axis must be perpendicular to each other. The couple is the same magnitude of forces but different direction, but they're separated by a distance D, which is perpendicular and separated this D. Okay, see you in the next new chapter, chapter number 5. Okay, see you again. Thank you. Bye bye.